now that we've had a chance to look at all these different types of combinations of two linear equations called systems of two linear equations, anytime we have two linear equations that we're working with together, whether it's in a graph with the equations or just thinking about the situation, that's always called a system of two linear equations. We've seen three types of these now, and we're just going to make sure that we know the formal names for these types of systems. So our first type of system, the one that we'll see the most often, is when we have two different lines that cross at one point. They might cross like this or intersect like this, where you have one line with a positive slope and one with a negative slope. But we can also see two positive slope lines that intersect. We've seen that before, or two negative slope lines that intersect. We've also seen that. When we're looking at the equations, we might notice that these two equations have different slopes. Anytime you have a system where the equations have different slopes, they will always be this type of system, these one solution intersecting lines. There's only one place the lines cross. There's only one point that is true for both, a solution for both of the equations. So that's one solution for the system intersecting lines. Our next type that we've seen are when we have these parallel lines. When we look at these types of equations, you'll notice that they have the same slope. So both of these equations in this example have a slope of 2, but they have different y-intercepts. So those are different. That's what makes the lines parallel. Because they are parallel, they will never, ever, 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 ever intersect. There will never be a point that is on both lines. That means that there is no solution. Parallel lines have no solution. Finally, there are these kind of weird ones where you type in two different equations or two equations that look different, but you only get one line. This happens when you have two equations in a system that are actually equivalent to each other. So we can see here, if we did the distributive property, we would get 1/2 times 4x becomes 2x, and 1/2 times 6 becomes 3. These are exactly the same. They have the same slope, 2, and they have the same y-intercept, 3. So when we have two equations in our system that are exactly the same, even if they don't look the same at the beginning, they're equivalent to each other. That makes one line, and that means that every single point that is a solution to one equation is also a solution to the other equation. And so these systems have infinitely many solutions. It just makes one line. They are completely overlapping 100% of the time. There are infinitely many solutions.